Alright, today we're going to do some solving quadratics. And so, the first three I'm going to do are the three different ways that we can solve quadratics by factoring. The first method is the greatest common factor. And because we have two terms, both with an x in common, I can make this 2x minus 3 equals 0. Separate it, x equals 0, 2x minus 3 equals 0. And remember, for all of these problems, we are going to get two answers. Now, they could be the same answer twice, but in this case, we got x equals 0 and x equals 3 halves. Let's do another one. Let's do x squared minus 8 equals 0. For this one, we don't have a GCF, so we're going to add 8 to both sides. I get x squared equals 8, and when I square root, I get x equals, break down 8 to be 4 times 2, 2 times 2, and x equals 2 square roots of 2. But when I think about it, that's only one answer. Anytime we do a square root on both sides, we need to remember that our answer will have a plus or minus. Alright, for this third problem, we have 4x squared minus 12x plus 9, which we're going to try to factor. What new numbers multiply up to be 4 would be 2 and 2. It also could be 4 and 1, but we're going to try on 2 and 2 first. And then what two numbers multiply up to be 9, we'll try 3 and 3. And I'm going to put both of these down as minus because this is a minus right here. So I'm going to check. And that's negative 6x. And that's negative 6x. That totals up to be negative 12x. So we got the same answer, which means we have 2x minus 3 and 2x minus 3 equals 0. Now it's silly to solve the same equation twice, so I'm just going to solve it once. And we get x equals 3 halves as our double root, because if I would have solved this one over here, we would have gotten the same answer. Alright, when we cannot factor, like in the problem that we have written down here, x squared minus 5x minus 7, we cannot factor this because there's no way that we could have negative 5, two numbers multiply up to be negative 7 and add up to be negative 5. So when we do this, we're going to do the direction, which is to find the discriminant, and then state the types of answers, and then we're going to find the answers. So the discriminant is b squared minus 4ac. And if the answer is positive, there will be two real answers. If the answer is 0, we will get one double root. And if the answer is negative, we get two imaginary answers. So in this problem, we have negative 5 squared minus 4 times 1 times negative 7, which turns out to be, and make sure when you put it in your calculator, the negative 5 is in parentheses, we're going to get the answer of 53. So since we got this, we know that there will be two real answers. To find the real answers, we're going to do negative b plus or minus the square root of b squared minus 4ac divided by 2a, which is better known as the quadratic formula. Now, because a equals 1 and b equals negative 5 and c equals negative 7, negative b is really the opposite of b, which is going to be positive 5. Since b is negative over here, it's positive. Now, we already figured out that 53 goes in the parenthesis or in the square root because that's the same thing as the discriminant divided by 2. Can we break down 53? The answer is no. So here's my answer. Alright, we're going to do it one more time here. First thing I'm going to do is add 10 because when we're solving a quadratic, it's always wise to get 0 onto one side. So b squared minus 4ac, which is the discriminant, is negative 3 squared minus 4 times 1 times 10, which turns out to be negative 31. So we will get two imaginary answers. So since a equals 1, b equals negative 3, c equals 10, we got positive 3 plus or minus the square root of negative 31 over 2 times 1, which is 2. Now, because we have this negative inside the square root, we're going to change this to be 3 plus or minus I square roots of 31 over 2. So when we do this, I'm going to write out both of the answers. The only difference in these answers is that the sign in front of the imaginary term, one of them is plus and one of them is minus. That is something that we call complex conjugates. And when we solve polynomials, that always happens. In the last section, when we had 3i, we needed negative 3i. If we have 2 minus i, we need 2 plus I. And if we have 3 plus I square root of 31 over 2, we need 3 minus I square root of 31 over 2. And that's it for this particular lesson.